I want to welcome you to the presentation of Evaluation of Safety Practices for Short Duration Work Zones. This work was completed by Melissa Finley from Texas A&M Transportation. The presentation will take approximately an hour, and at the end of the presentation, we'll have an opportunity for question and answer. So I ask that you keep your phones muted until that time. With that, I turn it over to Melissa Finley via Texas.
Good morning, everyone. Thank you. Appreciate that. We'll go ahead and just get started today. Before we get into the research efforts that we've completed, I would like to acknowledge some of the partners that we had in this research. Of course, the Ohio Department of Transportation. I want to thank Jill and Sean, who were heavily involved in the project, but I know there were many others as well that were involved, and we thank them as well. And I want to highlight our partners with the research. I had many individuals at TTI that helped, but in particular, I want to recognize Luann Tice and Jerry Ullman. I also want to recognize our subcontractors, Cleveland State University and Jacqueline Jenkins and her team of great students who help us collect field data, as well as the Texas A&M Health Science Center School of Public Health, Adam Pickens and Bark Benden, who helped us do the work with some of the ergonomic data that we're going to show you today. The overall research goal of this project was to identify cost-effective and safer alternatives to current procedures used by the Ohio Department of Transportation maintenance crews during single work shift maintenance operations. So I know that the title of the project says short duration, but it really involved a lot more than what you may consider short duration activities. In the Manual on Uniform Traffic Control Devices, it has a specific definition for short duration, which is typically an hour or two, maybe even less. Doesn't include overnight operations and doesn't include mobile operations. And that's really not the narrow focus that the Ohio Department of Transportation wanted for this project after we got started. And so we kind of, while the name still says that, we really opened it up to single work shift maintenance operations. So these could be a whole day, or these could be a whole night. They could be mobile, stationary, etc. So I just want to make sure and point out that difference so that you realize that as we go through the research progress and the results. Phase one, it was broke into two different phases. Basically, we had phase one, and in that phase, we reviewed the current ODOT procedures. We identified potential new strategies and technologies. We then conducted a preliminary assessment of these alternatives, and then we recommended some alternatives for further evaluation in phase two. So in phase two, we actually purchased and evaluated those recommended alternatives. We also organized and conducted a demonstration of full matrix truck mounted changeable message signs. It was one of the alternatives that we had mentioned, and the maintenance crews there in Franklin County were interested in looking at those devices, but not really us testing those devices. And so we hosted a demonstration that brought together a bunch of vendors so that different ODOT employees and staff could look at those technologies, talk to the vendors directly, kind of in a show and tell kind of environment. I'm not going to say much more about that today, but wanted to let you know that that is something we conducted, and there's a little bit of documentation on that in the final report. Then at the end of the project, we have recommended some of those alternatives for implementation, and we'll get to that at the end of the presentation today. So I want to quickly go over phase one to give you a little bit of background information. I'm not going to go into as many particulars as are in the research report because we want to get to the phase two findings, but I at least want to give you some background so you know where we were coming from. In phase one, we basically followed and reviewed 15 different maintenance activities. These were mainly in the Franklin County, Columbus area. Again, these were mobile and stationary operations. Some were day, some were nighttime. The majority were on high-speed freeways, again in the Columbus area, and the majority were single-lane closures, even though we did have some that were two-lane closures. When I say high speed, I'm referencing basically roadways that were 55, 60, or 65 miles an hour. Based on these observations, we identified different procedural and equipment safety enhancements that we thought might be applied by the Ohio Department of Transportation. And I want to first walk you through some of the procedural safety enhancements. These don't necessarily call for adding any kind of equipment, but they just need to be recognized and applied in the field, and most likely applied in new employee training or in training that your staff does on a periodic basis, kind of refresher training. So the first safety improvement is just to pull over periodically to allow traffic to pass. This can be when a convoy is going to a work site or once they're at a work site. We did see a couple of instances where some queues built up and we had some impatient drivers, and we want to be aware that as impatience grows, motorists do take more risky behaviors, which can lead to safety issues with the motorists, and then that can impact the safety of our work convoys as well. So if you have the ability, I know in some places it's not always available space to pull over, but if it is there and you notice a queue forming, we suggest that you periodically pull over and let that queue kind of dissipate so that you reduce that impatience and that propensity maybe to take higher risks to pass the convoy. We also noticed on a couple of different occasions that work vehicles were actually parked in merging tapers. Merging tapers are where the motoring public transfers from a closed lane to an open lane, and you do not want any kind of equipment or work going on in that area. Equipment such as your shadow vehicle can sometimes be located in part of your buffer area, but really your work area, activity area needs to be downstream. And so you need to be aware that if there's work to be done where the merging taper is, you need to back that up so that you have your merging taper out of your work area. And this is just a picture showing one crew that was working there in a merging taper area. In some instances with the night work, some vehicles would be left at a certain spot and then they would progress down the road. And I know sometimes there are questions about vehicle warning lights, about their intensity, you know, the possibility of maybe them being a distraction in their self. But we also don't want a large hazard left in a dark area inside the work zone that a motorist can't see. So if you're going to leave something, at least leave a light on, leave something that they know there's a piece of equipment there. Because if they did have an emergency or something that would require them to pull over there, you don't want them hitting a piece of machinery or a truck that doesn't have anything kind of illuminated on it to let them know that that's there. So just something to consider. We also want to make sure that our temporary traffic control devices are not like they kind of are on this trailer shown in this picture. We have the sign and it's just being stored and carried to the site, but someone may think you're a mobile operation and think that the right lane is closed, and that may cause some weaving and some different reactions from the motorist that we don't want, that could impact the safety of the convoy as it's traveling to its site. So just be aware that your traffic control devices need to be stored in such a manner that they're not going to potentially confuse the motoring public. Another one that we noticed in the field was that some of the crews were just making one pass to set up the dual advanced signing, and so they would work on one side of the road and they would actually travel across the lanes on foot to set up the sign on the other side of the road, especially at night. So we thought this was a negative impact on safety from the worker standpoint because of the low visibility of the worker. We'll talk a little bit later about how when we initially watched in phase 1, the majority of the workers were wearing only class 2 high visibility apparel, which just highlights the upper body. As you can see in this picture here on the right, there is a worker standing in front of that sign and how hard it is to identify that worker. And you can imagine folks traveling in a vehicle with just headlights, 65, 70 miles an hour again, and you have this worker on foot. And it's also important to point out that the worker's across from the work truck. And again, that work truck did have lights, as it should, but if a motoring driver is looking at that work truck and trying to stay away from that work truck, we want to make sure they recognize the worker as well. So we feel it would be best if you made one pass on one side so that your workers are near that truck, and then you circle back around. I know that adds a little bit of time, but we feel that that improves the safety of the workers. In a couple of instances, we just noted that the shadow vehicles that were used with mobile operations were either too close to the workspace, which would not allow enough roll-ahead distance, or they were too far back that would allow too much for vehicles to cut back into the convoy. And we realize this is a very hard thing to do. You want to sometimes pull back so that you have enough sight distance, but you also want to protect your workers. So we just think, again, in training, you need to just go back over these issues, go back over these trade-offs with positioning your shadow vehicle so that your drivers are aware of the need for the buffer space so that you can't make that too large of an area because of the potential for cut-in of the motorists again. Along the same lines, sometimes we need to make sure that the messages and the positioning of an advanced warning vehicle that may be on a shoulder, giving advanced notification of a mobile convoy that's down the road or advanced notification of a lane closure, that they are positioned correctly and safely, and also that their message is conveying the correct text or symbols to warn of that upcoming hazard. And then last but not least, just something that you may think about with your maintenance crews. It doesn't have to be a formal development of internal traffic control plans, but there are several documents out there. There's one recently through the Work Zone Safety Grant Program that just describes internal traffic control plans. And it just helps you in your safety meetings before you go out to talk about how many vehicles are going to be there, what kind of equipment's going to be there, how are you going to get in and out of the temporary traffic control, where are you going to stage potential equipment or materials, so that you're aware of that and you're aware of where your workers might be standing or actually doing the work. And so we just think, at least thinking through that before you go in the field can have a positive impact on the safety of your workers. All right, so now I want to talk just a little bit about some potential equipment safety enhancements that we identified that might be helpful based on our observations from phase 1. And I want to start out with some of the observations that we had for setting up and removing temporary traffic control devices. So in phase 1, we saw several workers, as you can see in these pictures, deploying and retrieving cones and drums from platforms that are several foot above the road surface, and that these workers on the platforms, as well as those in the back of the trucks, were unrestrained. Researchers were concerned that these workers might fall off the truck or the platform into active traffic lanes or be exposed to other ergonomic risk factors associated with upper extremity musculoskeletal disorders. Researchers wanted to investigate methods that would remove the need for workers to be on foot as well. So in some of the, I know in these pictures you don't see workers on foot, but a lot of times in phase 1, we would see a third worker outside the truck actually straightening or positioning the barrels or cones, and we were hoping to get the workers off foot as well. So a couple of things that we wanted ODOT to consider was modifications to their existing equipment that may improve or remove the fall hazard and help with removing workers on foot. Also, there were some specially designed vehicles that could just be used for maintenance of traffic or setting up and removing temporary traffic control devices that would be dedicated, that would hold all the devices. In the Columbus area for the night crew, a lot of times when they had dual lane closures, they used what they called the rack truck, and that's this truck that you're seeing on the left side of your screen. That's the daytime picture with the barrels. That rack truck could hold some barrels and some tall cones, but for a dual lane closure, they actually also used what they called the fast van, which is the picture in the nighttime picture, to have the signs as well as additional cones for the tangent. And so they were really hoping to get a vehicle that could do that so that they would be able to work from a single vehicle and, again, remove the need for that worker to be on foot and help with those fall hazards. Other devices are out there that help attach to vehicles that help you just move channelizing devices so you don't have to have that worker on foot. And there are completely automated systems out there that can drop cones, pick up cones, etc. And so we, again, just identified those as potential items that ODOT may want to consider. We also noted at night that the maintenance areas were in general well lit, but that maintenance workers on foot and on equipment frequently moved into and out of the area eliminated by the portable work lighting. So this is a picture from one of the night operations. You can see that the area is fairly well lit. The truck pulled the light tower ahead so that it kept up with the work area. The light tower was aimed really well from the oncoming glare issue for a motorist in the adjacent oncoming travel lanes. But off to the right, you can kind of make out in the shadows the roller. And the roller actually lagged behind and would come in and out of the lit area and really potentially had a hard time seeing where they were working. And so this repeated change in lighting can negatively affect the worker's visual capabilities, and then again can lead to them working in shadows or outside the illuminated area. So to eliminate the shadows, there's a possibility of adding equipment-mounted task lighting to these pieces of equipment, and we could also potentially use personal task lighting, so lighting that affixes, say, to a hard hat that would allow the workers to have a pointed light source that would be around them that we could focus on the task area. Under dark conditions, the retroreflective material on the high visibility safety apparel is the only component that provides motorists with a visual cue that the workers are present. In phase one, researchers observed that the majority of the maintenance workers in Franklin County only wore performance class 2 high visibility safety apparel at night. In this picture, you can see one gentleman who's wearing class 3s. That's a gentleman who has a class 2 vest on and then the pants, the fluorescent yellow pants. But everyone else was just wearing the class 2 vest. And again, we'll talk a little bit more about those details in a little bit, but just wanted to point out that, again, the class 2 vest only highlights the upper body. And it's nice to be able to get a little bit more of the entire body visible at night. And so a way to do that is to move to performance class 3 apparel. And that can be done several different ways. And I will, again, explain that in more detail in a second. So this is an example of a picture of a paving operation in Texas where they've added balloon lights to help with the equipment-mounted task lighting. And then this is just a picture also in Texas of some workers. I know this is a daytime picture. And class 3 performance apparel also helps during the day because it has a lot of fluorescent background associated with it. But again, it helps at night as well because you have the retroreflective strips on the lower body if you wear the class E pants or on the sleeves of a class 3 performance vest. A couple of other equipment safety enhancements that we identified that weren't necessarily associated with something we witnessed in phase 1 as part of the reviews, but we were thinking about the protection of the workers, so we wanted to make ODOT aware of 2 different ways of providing positive protection. One is the use of a mobile barrier, the other would be the use of portable steel barriers. There's also several states that have successfully been using temporary rumble strips to warn of lane closures. These can be used not only on 2-lane roads, but again, several states, Texas being one, has been successfully using them on freeways. Again, I mentioned earlier the use of full matrix truck-mounted changeable message signs. Full matrix signs allow you not only to provide text, they allow you to provide symbols. They actually can also be used as the arrow board, so you don't have to have a separate arrow and a CMS anymore, or one or the other. This actually can combine. And so for your advanced warning vehicle specifically, you can tailor more specific messages than just having a 3-line, 8-character PCMS that you have to tow on a trailer. It gives you a lot more versatility in what you would use. Now, you do have to watch out what you're posting still. There are rules to follow with respect to the messages and how many messages you need to be using on high-speed roadways, and you need to make sure you're following those. But it does allow you, I believe, to have a lot more flexibility in what you want to tell the motorist. And again, it's mounted on your truck and can be used as an arrow panel. So even when you're not using it as a CMS, it can be used as an arrow panel. The last thing that we wanted to make sure ODOT was aware of was just intrusion alarms. These can be used to alert workers to errant vehicles. Traditional intrusion alarms, some of them affix to cones. There are ones that are coming out that use newer technology that can attached to vests and can vibrate or do different things to the workers to let them know that there's the potential for an errant vehicle. So based on all that information, we provided an interim report to the Ohio Department of Transportation, and we met with the folks that are helping with the panel for this project, and they decided that they wanted us to study the equipment that's listed here. Again, the procedural aspects that I just discussed could be implemented through training, new employee, as well as refresher courses. And then I gave you a laundry list of different types of equipment. And again, in the final report, that's all explained if you have interest in one that we potentially didn't evaluate. But these are the ones that we went forward with in phase 2. We looked at modifying existing temporary traffic control setup and removal equipment. One way was we added a worker basket instead of just the open liftgate platform. And then we also looked at 2 different dedicated maintenance traffic trucks, one that was built by the Columbus area folks, and then one that was purchased from a commercially available vendor that was being used in Cleveland. We also looked at the performance class 3 apparel, personal task lighting, and equipment mounted task lighting, and then we also looked at the mobile barrier. And this, going through these pieces of equipment, is what I'm going to spend the rest of our time on this morning, and giving you some details about those evaluations. So let's start with some of the things that we looked at that would change the way that temporary traffic control devices, mainly we were looking at short cones, tall cones, and drums that would be set up and removed for your maintenance work areas. The research team used a field study and an ergonomic analysis to compare the existing and proposed methods of placing and retrieving temporary traffic control. I'm going to walk you through both those studies. First of all, I wanted to discuss a little bit of the existing equipment more in detail than I did just a minute ago. So we see one type of existing equipment, again, was basically a pickup truck that had a lift gate. Typically, one worker was in the back of the truck while another worker was on the lift gate, and they would deploy. Again, mostly these was daytime operations, so it would be short and tall cones. We also have what we call the rack truck, again, which was used in the Franklin County area, specifically a lot used at night as well, even though this is a daytime picture where they were doing some activities with it. It, again, could hold some tall cones and barrels, but not quite enough for multiple lane closures. It similarly has a lift gate. We also have, again, the fast van, which was more like an old box truck that would hold extra materials that could be deployed. And then also in Franklin County, there's one yard that was using this trailer that is shown here. And you can see some barrels, again, the tall cones, and the barrels are separated from their bases, but the tall cones are stacked with their bases affixed. Researchers also, when we were in Cleveland area, really specifically going to look at their dedicated MOT truck, we happened to come across 2 more uses of trailers, and so we have a little data on those, and just wanted to go ahead and show you a picture of those. I can bring this back up later as well, but they're made a little differently than the one in Franklin County. So the top one just has a shorter railing on it, mainly used for drums, and then the one in the lower part of the screen on the right does have a different kind of railing around it, and you actually deploy the traffic control devices from the rear of the trailer. So we're going to first talk about the ergonomic assessment. So we wanted to look at the potential for, again, musculoskeletal problems or disorders that may occur because of the way they were deploying and retrieving devices, as well as the potential, again, for the fall hazard, and trying to look at ways to mitigate that. So this is the pickup with the liftgate, and I have a couple of different pictures showing how they deploy, again, short and tall cones. The liftgate was approximately 10 inches off the road surface, and again, this crew consisted of 3 individuals, 2 in the truck and 1 on the road. So when installing the tall cones, one worker was located in the bed of the pickup truck. Here you can see what he did is he separated the tall cones, their bases, because of the limited area here, their bases were separate. So he separated the tall cones, which were stacked for transport, placed the base over the cone. You can see that in the picture. And then he set the assembled cone on the lift gate. So he had kind of a leaning activity as well. This worker had the highest risk tasks for musculoskeletal disorders due to the repetitive arm motion of abduction, outstretched arms, and bending. So a lot of what you'll hear today is not, I'll try to point it out. Some of it is deployment method specific, and some of it is just from the cones and the drums and how much they weigh and the fact that we have to assemble them. And so while that's kind of the solution to that may be outside the scope of this project, we wanted to make sure and mention it so that as we move forward with research and we consider ways maybe to mitigate these, because the repetitive motion of doing this over and over on a daily basis, setting up cones, setting up barrels, can lead to issues at some point. And so we want to just kind of go over all those, but I'll point out which ones can be maybe mitigated by other ways of doing it, not just from a lift gate kind of a thing. So I just wanted to point that out. We also had some issues when we retrieve. So you can see this gentleman on the lift gate, when he's retrieving the tall cones, has to repeatedly bend over to separate those devices, and then he hands both those up to the gentleman in the back of the truck. The short cones were similar, and you might think, oh, short cones weigh less, so they shouldn't be as much of a problem. The issue is that even though they're lighter weight, they are shorter. And so since they're shorter, they did stack them more. And they also have to lean over more to pick them up and set them out. So whereas the tall cones, you can see the gentleman on the top row, while he's setting it out, it might be heavier, it's at his same kind of a waist height level. Versus the short cone on the second row, he really has to lean over because of its height. So therefore, separating the short cones because they were stacked higher and placing the short cones did result in some high to moderate risk for musculoskeletal disorders. The main factors were the position of the arm, the repetition of lifting in conjunction with the body and arm postures, and the bending over. And so we see some issues with both types of cones from this kind of lift gate assembly. The rack truck also had a lift gate. And so some of the, there were some similarities, but we mainly looked at the cones and drums from the rack truck, the tall cones, excuse me. This was a 3-person crew as well. The tall cones in this instance, though, however, were stacked as one-piece units, so we didn't have the need to put the base, lift the base over the head and put it on the cone. The bases didn't have to be, or weren't separated because there was limited space in the back of the truck, and so they just stacked the cones. But this did require the worker to separate the tall cones and move them into place for the second worker to place on the roadway. So although we didn't have to lift the base, depending on how tall the stack of those cones were, they were still lifting the whole assembly potentially over their head. Sometimes the need to separate stuck cones or barrels constituted what they call a repeated shock. The shock was significant due to the need to pick up the entire stack of cones and work as a team to separate them. And while this task didn't occur all the time, it was observed to occur about 40% of the time. And so that can cause some issues with the risk. During the pickup, that's a picture of them lifting over their head. I know it's a little hard to see at night, but you can kind of see that cone over their head. During pickup, the main concern was the movements required to stack the tall cones. Again, this varied based on the stack. The tallest stack that we measured was 75 inches high, and again, that was requiring them to lift those over their head. Pardon me. Researchers also observed drums being distributed and retrieved from the rack truck with the lift gate. Most of the drums and bases were stacked. During pickup, they were stacked separately in the back of the rack truck prior to deployment. For deployment, one worker again was located in the back of the truck while the other one was located on the liftgate. The one in the back of the truck is the one that puts the drums together and would move the base together and then push it to the back of the rack truck. There was a high risk here just from having to unstack the bags, the barrels again, or the drums. Again, sometimes there was a repeated shock because the barrels wouldn't come apart and they had to work as a team to do that. So some of the similar issues that we saw with the cones also happened with the barrels. During pickup, the concern was mainly due to the mass of the assembled drum because it had to be repeatedly lifted. Again, that's a problem. So again, these are things that we see between the two liftgate types of trucks, and it has to do with the putting together, the assembling or disassembling of the temporary traffic control devices and the transfer of those in and from the upper platform to the lower platform. And I wanted to mention that while not in these pictures, again, most of the time, there was at least one worker on the ground on foot that would help position those barrels and cones into place. So this is the trailer that was used in Franklin County. During the day, we observed the deployment and retrieval of tall cones from this trailer. Again, the tall cones were stacked as one pieces on this trailer. Most of the placement and retrieval tasks from the trailer did not result in high risk for the musculoskeletal disorders. The high side of the trailer provided fall protection, except in the area where the tall cones were being deployed, and you can kind of see that in the picture on the right and the left. At the two sites in Cleveland, researchers observed nighttime crews using these trailers. At the Cleveland garage, which is the one, I believe, on the left, the workers used a trailer with a sidewall approximately 12 inches high from the base of the trailer platform. One worker disassembled the stacked drums on the bed of the trailer platform and put the bases on. Another worker lifted the assembled drums over the side of the trailer and dropped the drum onto the road surface. Again, a third worker was needed to place the drums after they were dropped on the surface. Researchers observed multiple occasions for the need for the worker to exert considerable force while pulling the stacked drums apart. And during pickup, separating the bases from the drums also resulted in high-risk tasks due to the mass of the base, the repetition of the movement, and the arm-torso position. Drum deployment and retrieval at the Euclid garage, which is the trailer on the lower right, was accomplished with just two workers and the trailer. These had side rails and had an opening approximately 12 inches from the road surface at the lateral rear of the trailer. Results of the ergonomic analysis for this trailer revealed moderate to high risk for the workers placing the drums. This task required, again, repetition, heavy mass transfer, and an awkward arm position. Basically, with the trailer, the pickup also resulted in similar types of hazards. And again, as I mentioned before, they do have some railings on these trailers. As you can see, one has a much lower railing than the other two, but there's still some issues for fall hazards in the areas in the rear of the ones with the side railings or on the side where there's a hole where you have to deploy the devices. So one suggestion was to try to use some kind of basket. There are different groups within the Ohio Department of Transportation that have fabricated their own baskets. And then there are baskets that are sold or that are commercially available. And so we wanted to try out one. Basically, we borrowed this basket from another group within the Ohio Department of Transportation. While you can see this basket has railing that helps on the, from like just having, versus just having the lift gate, we do still have the issue of the gentleman in the back of the truck who is unrestrained. Workers use two methods for deploying the tall cones from this basket. They used an over-the-rail placement, as you can see in this first picture. and they used an under the rail placement. The ergonomic analysis revealed that the under rail drop technique presented low or minimum risk for upper extremities and the whole body, versus the over the rail method provided a higher risk for the operators. So we did not recommend that that be used. And this was a learning activity because these groups had not used the basket before, so we kind of allowed them to try different things, and that allowed us to assess those different ways of deploying devices from the baskets as well. I do want to point out that some of the same issues with unstacking, stacking, and transferring the devices between the upper and lower platform still exist with this device. It basically was suggested and tested to help provide the fall protection for the worker on the lower platform. Again, the fall protection is still lacking for the worker in the bed of the truck. This is during pickup. So during pickup, the worker's task consisted of an initial coupling, a swing over the basket rail, and a lift into the truck. It wasn't as easy to kind of pick it up under the rail, so we didn't notice that as much. This unfortunately did lead to higher risk due to the worker having to constantly lift overhead. And there's the potential for the worker to raise the top rail. So as you can kind of see if my clicker will show up on your screen. I don't know if it will or not, but there's a rail right here that you can actually raise, and it's the same way on the other side where the worker is standing. However, if you raise that again, you lose your fall protection. So unfortunately, it's you have to choose one or the other. And again, we're just pointing out the different ergonomic issues associated with lifting and transferring, but there's a balance there between providing some of that and providing some of the fall protection as well. And you just need to be aware of both going forward. And again, this project, while we did see some ergonomic issues with the unstacking, the stacking, the mass of the devices, that really was a little bit outside the scope for us to apply solutions to, but we wanted to make them apparent and document those, so moving forward, there may be additional considerations for those. All right, we also looked at 2 dedicated, what we call maintenance of traffic trucks. This is the new Columbus MOT truck. This truck was designed by ODOT staff and fabricated, the fabrication was outsourced. The upper platform was designed to be longer to allow that sufficient storage of the drums and tall cones so they wouldn't have to use that rack truck and the fast van anymore. The upper platform has side rails, and the lower platform on each side was designed with a gated area for the worker and an open area to allow deployment of a drum or a cone. So there's a smaller picture down here because it's all black, it's kind of hard to see right here. But on each side of the truck, there's a place for the person to stand right here that's gated, and then a place for you to put the device. And you can see it a little bit better here. You see the drum here could be placed into this hole and then on the roadway, and then this has the railing for the fall protection for the worker. And this can be changed to the left or the right depending on how your worker prefers to function, and then again, it's on both sides of the truck. So one of the first things we did is an assessment of the ergonomics just in the yard, kind of looking at the different design ways you could remove railing, add railing, and so we want to take a look at that. So we measured the characteristics of the truck, investigated the design, and then identified potential uses. We did an analysis both for an assembled drum and an assembled cone, and we set it up in what we thought would be the primary use configuration. And so that's as you see here, with a closed basket on the left, you can kind of see right here, the open platform on the right, and then this would be where the upper platform worker would stand if they left the fall protection in place. So there is fall protection on this MOT truck for the lower and the upper platforms, but as I'm about to point out, there is some concerns over leaving that fall protection on the upper platform in place. So the primary contributing factors for high-risk activities on the upper platform deal with the upper arm and torso combined with the mass of the drum or the cone. So if you used it as set in these pictures with the fall prevention panel, in the upper area, like shown here. This is Adam, one of our Health Science Center folks. You can see he really has to lean over to get that drum, and Adam is a fairly tall guy. So for all but the tallest individuals, the current design actually presents more of a fall hazard because more than 95% of the working population would not be capable of leaning over to grasp the item to be lifted. Combine that with the significant risk to the upper extremities and the lower back, that current design creates significantly more ergonomic hazards from the leaning standpoint. Again, obviously it's trying to solve the fall prevention, but it may actually also be contributing to that depending on the height of the person and how they have to lean over to get that mass. So we also watched how they actually use it in the field. And as you can see in this picture in the field, because of that issue with going over the railing, I'm going to use my arrow again. Hopefully you can see it. In front of the barrel and the person on the upper platform, they have removed that railing so that they can just place it immediately down. The railing is still in front of the gentleman that's on the lower platform. So unfortunately, that requires you to remove the fall protection that was initially designed. We did the same kind of ergonomic analysis on this for these two different workers. For the deployment, the main task mirrored those a lot of the existing methods of transferring down. Because there is a mass, but you're going down with gravity, you don't necessarily have as many issues, and the weight of the mass of the drum helps it deploy down, and the lower platform is at a good height just to be able to transfer that onto the roadway surface. But here are some pictures of various workers trying to lift the drums back up to the upper platform. So for the retrieval, the worker on the lower platform picked up the drum and placed it on the same level working surface that I showed you in those other pictures. And as you can see up top in the top picture, the second worker then had to lift the assembled drum onto the truck bed using a squatting or bending posture. As you can see in this figure, the worker is being pulled away from the bed of the truck by the mass of the assembled drum and in the squat posture. This combination creates a significant risk for falls. So unfortunately, it's the retrieval, especially if you think of them hitting a bump or just losing their balance, that they could topple because they really are having to lean and strain to pull that barrel back up. We also looked at the Cleveland maintenance of traffic truck. Again, this was one that's commercially available, and they had purchased several of those in the Cleveland area, and so we wanted to look at them. This truck is not as long as the one in Columbus, also because of the truck-mounted attenuator that is used. It kind of limits the storage space. You can see some short cones underneath the TMA and just tall cones, but it makes it difficult for them to deploy drums from this truck. It does have an area where the person stands. I'll use my arrow again, and has a bar across that for the fall protection. This version of this truck did not have a platform next to it like the Columbus truck that allowed for a device to be put down on the same level surface as the person. You can see in the lower nighttime picture, there's lots of task lighting or equipment lighting that helps illuminate the roadway where they're placing and picking up the drums. And then you can see how that bar for the fall protection moves over or out for people to get into. There's also a step in this one. That step was not used to put any of the devices on for transfer. It's mainly just for someone in the upper platform to step down into the lower platform. Since only tall cones were mainly deployed and retrieved from this vehicle, the worker on the upper platform did not have to bend over as much as in the Columbus truck. So even though falls from the upper platform were still a concern, because again, you see all this right here, it would be hard for a person to put a cone over the rail to be able to hand it to a person here. And so basically they also removed this railing in the Cleveland truck when it was active. similar to what they had to do for the Columbus truck. So falls, again, were a concern. But since, again, it was a little lighter weight, it wasn't as extreme as it was with the barrels. To retrieve the tall cones, again, the worker on the platform, lower platform actually had to pick up the cone, invert it, and then place it in the truck bed. So instead of being able to bring a device again to that same level plane, they had to pick it directly from the road and transfer it to the upper platform. So that actually caused a little bit higher risk for that person than in the Columbus truck because of the way those platforms were designed. So overall, I just kind of wanted to give a big snapshot. I know I just ran through a lot of information. And again, some things are just ergonomic issues because of the design and the mass of the barrel and the cones themselves. And then some things are actually dependent on the vehicle or truck used. When the proposed and the existing methods are compared, there are several conclusions that can be drawn. For both dedicated MOT trucks, individuals placing and picking up devices from the lower platform were presented with less risk than those on either the lift of the pickup or the rack truck. This is not because of changes in the ergonomic risk, but because of the closer. So it's actually from the fall risk or the hazard. The body movements were much the same for the individual deploying and retrieving the traffic control devices from the road surface, resulting in a similar risk. The new enclosure, on the other hand, worked well at minimizing the fall risk for the individual performing this task. The new enclosure also worked well at not presenting new hazards while minimizing the known issues, again, that we just have with the devices themselves. The same cannot be said for the individual in the bed of the dedicated MOT truck. So that would be the upper platform in this table. The lifting and lowering of devices from these truck beds to the lower level presented significantly more ergonomic and fall risks. The height difference between the bed of the truck and the lower level surface caused the individual lifting or lowering to have to bend over to below foot level to lift lower all the items for placement. This not only presents a high ergonomic risk, but a significant safety risk for falling. The designers recognized the potential for the fall hazard and included a removable protection panel. However, the height difference between the truck bed and the lower working surface with the protection panel in place is all but unusable for the average working population because of their height. The workers never used the protection panel during the researchers' observation period. Either a fall protection restraint system or an appropriately designed railing could mitigate this risk. However, it's unknown whether the current dedicated MOT trucks could be retrofitted with fall protection restraint systems because there are standards they have to meet, different loading, etc. And so that would have to be looked at by an engineer and determined if they could be added to the existing systems. All fall protection equipment, again, would need to be overseen by a qualified professional engineer. And another option to reduce the ergonomic and fall risk would be to install an automated lift. So that would help remove or mitigate the need for bending if you could have a lift that would take the devices from the lower platform to the upper platform. Researchers found similar results for the basket truck. The lower basket does offer potentially decreased ergonomic risks for most tasks because of the flexibility afforded by the open rails of the basket. However, lifting and lowering over the top rail of the basket did introduce greater ergonomic risk. The under rail placement is preferred. The lower basket's primary advantage is in the protection of falls from the worker that's on or in the basket. Conversely, though, the individual in the truck bed still is a significant risk from falls in the moving vehicle, although this was also the case with the trucks with the lifts currently used. Either appropriately designed fall protection restraint system or railing could again mitigate this risk. So that's kind of the ergonomic and fall risk assessment. We also did some measurements in the field, just trying to identify the retrieval and placement rates, trying to compare the different methods. Obviously, the maintenance crews are very familiar with the current methods they have, and we wanted to ensure that if we changed up those methods or added a different truck, would it positively or negatively or neutrally impact the rate at which they could deploy and pick up devices. So what we kind of in general found was that the pickup with the lift gate was the slowest way to deploy and retrieve. We think this is because the driver of the pickup truck drove slower because they realized they had individuals in the back of the truck without any railings and on the lift. The pickup with the basket was faster, but it was highly varied, mainly because, again, they hadn't used this basket very long. We saw the different deployment methods, and that affected also how fast or slow that the devices were set out, or picked up. Overall, the dedicated MOT trucks were seen to have the fastest pickup and removal rates. But even when you looked at all the numbers and you compared slow to fast, and you looked across cones, tall and short, and barrels, we looked at applications in merging tapers and tangents. Basically, when you did a little bit of observation of it, you could tell there was really no practical differences among the methods. So while some appeared slower and some faster, when you got down to the practicality of it all, we feel that they were all very similar, which is still very encouraging, because it's not that we are introducing something that would add additional time to the setup or deployment of the temporary traffic control. Now we're going to switch gears and talk a little bit about the worker apparel. So in phase 2, researchers compared 2 worker apparel options to the current standard and conducted a photometric evaluation to visually compare the worker apparel options with and without personal lighting. So real quickly, just want to mention that ANSI 107-2015 defines performance classes. ODOT is currently wearing Class 2 vests that are shown here. Class 3 could just be the vest that's shown in this picture, or you can add Class E supplemental pants to a Class 2 vest. These garments are required by federal standards, and the MUTCD extends these provisions to workers on all roadways in the United States. We also wanted to look at personal lighting. And to do that, we actually, the Ohio Department of Transportation decided that they would purchase some halo lights. These lights were for the night crew in Franklin County. These lights attach to the your hard hat. They provide 360 degrees of light around a worker. There are 4 different light modes, basically the intensity of the light. We just looked at 2 in our study, the brightest and the dimmest. The versions that we purchased, it was a while back, were corded with rechargeable battery packs. Halo now makes a cordless light that just runs on one battery. So I just want to make sure and bring that to y'all's attention, so if you go to look into these now, you would realize that they don't require a corded battery pack anymore. For the photometric evaluation, what we did was look at several different treatments. We looked at the Class 2 vest on a mannequin, as you can see here, and we looked at a Class 3 ensemble. This again included the Class 2 vest and the Class E pants. The guys at night, and ladies, in the Franklin County weren't as interested in wearing the vest with sleeves because of their concerns for it to limit mobility and potential for it to be hotter, and so they were more interested in just trying out the pants. And again, we looked at the halo in the brightest, dimmest, and we also had situations where we didn't use it or it was off. Basically, we looked at the luminance, and luminance is a measure of light reflected from a surface or emitted by a light source and is roughly equated to its brightness. Researchers measured the luminance of each ensemble and halo configuration under 2 lighting conditions, light and dark, 3 different positions. You can see that here in the graphic. So one position, the mannequin was right near a balloon light, which is the square in this graphic. Sometimes the mannequin was in front of the light, so between the vehicle and the light, and then sometimes the mannequin was behind or past the light. We also looked at 2 lane closure configurations, a right and left lane closure, and we positioned the vehicle in the lane immediately adjacent to the work area and then 1 lane over. The vehicle itself was parked 300 foot upstream of position 2. This length represents the distance a vehicle going 70 miles an hour travels for the time of a driver to recognize the existence of an object in the roadway ahead until the driver actually applies the brakes or takes some kind of evasive action. findings from this study. What we did is we actually looked at the silhouette luminance. So we wanted to say, what does a person see? Instead of focusing on maybe just the individual strips, we wanted to take it as a whole body of a person, like we'd like the worker to show up. And so to do that, we used this area that's shown in the picture on the right, and then we wanted to compare the silhouette luminance from the Class 2 to the Class 3 garments. So what you're seeing in this table is the percent change from just having a vest to the ensemble that's shown in this picture, and this was without the halo. I'll get to the halo data in just a second. What you can see is since these are all positive numbers, it means that we had an increase in the luminance, which makes sense because we're adding more retroreflective material. Overall, the increase in the luminance ranged from 17 to 240%. And again, you can see how it designates more of the body of the mannequin, not just the upper portion, but the legs as well. This is another way to look at it with a graph. You can see here, it shows the benefit of adding the classy pants, especially for the left lane. So when you're in the left lane, I don't know how many of you are familiar with how headlights are set up, but headlights are aimed down into the right to reduce glare to oncoming traffic. And so when you have a left lane closure, you're not getting as much of the headlight illumination on your workers. And so we can really see the benefit of that extra retroreflective material in those kinds of setups. Now this is some data where we had the halo off versus the halo on, and it shows the two different modes. Basically, we can see the average change in the silhouette luminance increased even more, and the brightest mode ended up being about 4 times brighter than the dimmest mode. And so this again adds to the ability to see your worker at night. There's a picture at the bottom. I know it's a little blurry because it's a nighttime photo and folks were moving, but you can see them in their Class 3 ensembles, and you can see them with their halo lights on, and how you can definitely tell that they're there. And then it also provides them with the task lighting they need to perform any work. And I'll show you a couple of more pictures in just a second about that as well. So we want to talk a little bit about visual angle. We want to make sure that folks can see the worker as they're approaching. So what we did is we actually backed up to 700 feet and wanted to see how the luminance would come out and what we would see. And so as you can see here, we took the treatments, the Class 2, the Class 3, and then we also just looked at the drums. We placed a few drums out there. We wanted to see what their linear size was, and we converted that to a visual angle, and then we looked at the percent change. So basically, a person with normal vision, so let's say 20/20 vision, has the ability to discern a detail of 1 arc minute, which is approximately 0.02 degrees. This means that at 700 foot, a person with normal vision would be able to distinguish an object approximately 2.4 inches tall. These findings show that the Class 3 ensemble increases the visual angle due to the addition of the retroreflective stripes on the pants. In addition, this table shows how the Class 2 vest and the drums have similar linear sizes and visual angles. So let's take a minute and look at not just the data in the top table, but the pictures below. So I again hope my arrow's coming up. If not, I'm going to try to also use my words to describe. Let's look at the black and white photo on the bottom left. So here is just a person in a Class 2 vest. You can see there are a line of drums, and this is the person. You can see if this was a shorter stature person, that would look a lot like a drum because the visual angle is very similar. And you can see that by the numbers in the row in the table above. When we add the pants, you can see, you at least notice there's something here which extends the visual angle of this person and allows you to start to distinguish that that may be something different than just a line of drums. We also can see that when we add the halo, we get another visual cue above showing again a larger extension and start to be able to make out that that's possibly a person and not just a drum. So we think that this is, again, showing the benefits of the Class 3 ensemble and the halo lights because it allows approaching motorists to better decipher that there are workers amongst the temporary traffic control devices. We also looked at adding equipment-mounted task lighting. In phase 2, we purchased 3 commercially available light-emitting diode balloon lighting systems. Each lighting system was powered through the equipment's internal power system and had approximately 23 foot of cable to reach the battery from the balloon light, and they affixed to telescoping poles. Once the systems were installed, the workers could quickly and easily mount the pole and balloon light upon arrival at each job site. We observed this activity and found that 2 workers could set the balloon light in the field in a matter of 3 to 4 minutes. ODOT chose to install the balloon lights on 3 pieces of equipment in Franklin County: a pickup truck, you see here, the asphalt paver that they have, and the roller that I mentioned previously. In phase 2, researchers measured the illuminance around the pieces of ODOT equipment listed above here, with and without the balloon lighting installed. The addition of these lights increased the illumination of the work area to levels at or above the minimum levels recommended by ODOT. So that is the minimum level of 55 lux. That's pretty standard for a lot of different states and has been recommended in a lot of different research to be able to see tasks around this type of equipment. And the increased illumination improved the workers' ability to see the work area and the work tasks, and they thought that it positively impacted their quality of work because they could see better. The balloon lights were easy to set up, and they also reduced the likelihood of glare to oncoming motorists. So last but not least, I want to go over some of the things that we observed with the mobile barrier. Based on the phase 1 findings, ODOT decided to purchase a mobile barrier to protect workers conducting their maintenance operations in Franklin County. Researchers observed the use of the mobile barrier shortly after it was received and again 7 months later. Based on a literature review, discussions with other agencies that use the mobile barrier, and ODOT's experience, researchers identified some of the operations for which the mobile barrier has been used and its advantages and challenges. So the mobile barrier is a commercially available product. It can be driven to the work site and moved around as needed. It can be used during the setup and removal of temporary traffic control as well as during the work activity. It can be configured to different lengths depending on the number of wall units that are used. The picture here kind of shows when they were assembling the barrier in a storage facility there in Franklin County. This is what we call a wall section, the upper right picture, and then it shows it installed. With one wall section, the overall barrier length is approximately 62 feet. With 2 wall sections, the overall barrier is approximately 82 feet. The mobile barrier can be configured for right and left lane closures. The system includes storage that you can see here to carry tools, equipment, and materials. And there are optional items that include power, lighting, signing, a truck-mounted attenuator, and the rear steer. In the spring of 2016, TPI purchased a mobile barrier for ODOT as part of the research project. The mobile barrier included the front and rear platforms, 2 wall sections, and a caboose with standard fixed axles. They opted also to buy an onboard generator, power, work lights, toolboxes, the TMA, and a changeable message sign. And here's a few pictures of the mobile barrier in use. In October 2016, we observed several types of maintenance operations where the mobile barrier was used. This included the barrier wall reflector replacement, which is seen in the upper left, graffiti removal, which is seen on the right, and the guardrail mowing, which is seen on the lower left. In addition, ODOT used this barrier for median barrier wall drainage structure repair. However, ODOT realized that certain repairs, such as partial depth concrete repairs, were not possible with the existing configuration because the rear caboose had fixed axles. So when trying to remove from one repair location to another, the caboose wheels would have crossed over recently repaired sections. So in early 2017, ODOT purchased a rear steer caboose. The rear steer caboose allows the crew to turn the rear wheels of the mobile barrier, allowing the mobile barrier to be more easily moved around when traveling to and from the work zone and from moving from one repair to the next. So this is a picture later on after they received the rear steer of being able to do that bridge deck repair. So now the rear wheels on that caboose can be moved around this patch and not drive through the fresh concrete. You can also see from these pictures, I'll go back one, you can see how the tools are plugged in, there's storage here, the lighting up here in the different pictures, there's lighting down here for the arm mower. You see again the lighting here in the storage. There were some separate tools and trucks needed for this, but not always. Some other types of operations that Franklin County has used this for include different mobile operations, the pothole patching, which is in the upper left, and then some sweeping, which is in the bottom right. So again, we feel that overall, ODOT successfully used a mobile barrier with many different types of operations, and some of those are used here. The addition of the rear steer caboose improved maneuverability, such that the mobile barrier could be more easily driven into and out of the storage area and around repairs. Based on the literature review, again, and discussions with other mobile barrier users, as well as ODOT's experience, we created this list of advantages and challenges, and I just quickly want to go through that. Some of the advantages, again, are that it provides lateral positive protection, has a whole bunch of onboard items that can be beneficial to the work operations. Again, the rear steer option, I went over that and how it can be beneficial. In some cases, it removes the, if you get the TMA, especially then on the back of the mobile barrier, which is recommended, it removes the need for an additional shadow vehicle to trail that vehicle. A lot of times it removes the need for spotters because you are behind this device that provides positive protection. And so you no longer need someone looking out for traffic that may errantly come into your work zone. It reduces the road noise in the work area. There is a higher level of comfort for the workers while they're working. In some cases, especially shoulder work, it requires a little less temporary traffic control setup. And it also blocks the motorist's view of the work, hopefully reducing their distraction of the work. But there are a few challenges, and some of these challenges improve over time. Storing the device with two wall sections, you have to make sure you have a facility large enough to house this truck. It can also be a little bit difficult to navigate depending on how many wall sections are included. ODOT did note that the rear steer helped improve this. Kind of in line with that, I know it's at the bottom of the list, but you also have to make sure you have qualified drivers that can drive this device, and it does require a permit because of its large size. For full roadway repairs, sometimes an additional lane must be closed because you need to move the barrier to the edge of the lane, and obviously it would impose on the adjacent lane. Again, certain repairs are not possible without the rear steer, but they do have that rear steer option. And then the time needed to switch the direction of the barrier, at first, because you're learning, that may take a little while, but it did improve as that happened over time, and it just depends on what you're doing the next night. So if you have a couple of nights in a row where you're all doing right lane closures, then that time is not necessarily needed. But if there's differences in a week or in a few days time period where you need a right lane closure and a left lane closure, you do have to realize that you're going to need to do that in your yard or in part of your prep time and account for that. So I want to go over the summary and recommendations, and then we'll open it up for questions. Overall, researchers evaluated existing and alternative methods of temporary traffic control setup and removal through field study observations and an ergonomic analysis and discussions with workers. While researchers identified some differences in the deployment and retrieval rates among the equipment used, the differences were not considered to be practically significant. Researchers believe the deployment and retrieval rates for the alternative methods were similar to those for the existing methods. The ergonomic assessment revealed several issues with the separation and assembly of tall cones and drums. In addition, the repetition of the tasks, mass of the temporary traffic control devices, and transfer between high and low platforms contributed to high risk for musculoskeletal disorders. And again, we saw this across several different types of the vehicles used. While the MOT trucks presented workers placing and retrieving devices from the lower platform with less risk than some of the existing methods, the potential for falls from the upper platform was increased because of the height difference between the road surface and the upper platform and the need to bend over to below foot level to lift lower devices. Even though the MOT trucks have safety railing around the upper platform, a portion of that railing must be removed during deployment and retrieval. Overall, every method evaluated exhibited significant safety risk for falling because of unsecured or unsupported workers on lifts, trailers, or in the beds of trucks. That's just something we need to consider going forward, is how to mitigate those. And again, we recommend that ODOT consider using additional fall protection restraint systems or automated lifts to raise these traffic control devices from the lower platform to the upper platform. Both of these measures could mitigate the fall and ergonomic risks. However, again, we need to make sure that the fall protection equipment, the system, the design parameters all need to be overseen by a qualified professional engineer to make sure that they're installed correctly. And again, we're not sure if the current trucks could be retrofitted or not. That would take a separate analysis that was outside the scope of this project. So for the worker apparel and lighting, we evaluated the effectiveness of changes to high visibility safety apparel, personal lighting, and work area lighting. The photometric evaluation showed the benefits of the Class 3 ensemble over the Class 2 vest. For all mannequin positions and lane closure configurations, the Class 3 ensemble increased the luminance of the worker. The increased visibility was most apparent when the mannequin was backlit. So that's when the mannequin was in the position between the vehicle and the balloon light. The Class 3 ensemble also increased the visual angle of the worker, which helps approaching motorists distinguish the workers from the line of drum. So overall, we recommend that Performance Class 3 high visibility safety apparel be worn at night, since it improves the visibility of workers and helps to distinguish workers from other temporary traffic control devices. The halo light also increased the luminance and visual angle of the worker, providing yet another visual cue that workers are present. The halo can be used as desired to further increase the visibility and provide individual work task lighting. What we did find is, as the balloon lights were implemented on some of the equipment, the need for the halo light for task lighting was reduced because they had lighting on the equipment. So there's kind of a trade-off there between those. And so that's why we wanted to leave the halo light to be used as desired, because it does help. But if you're using other illumination techniques, it might not be, for the task lighting aspect of it, as needed, because you have the light from the balloon light on the equipment itself. So leading into that, the equipment mounted task lighting. Basically, we evaluated the balloon lights, the addition of them to several pieces of equipment. This increased the illumination of the work area to levels at or above the minimum level required by ODOT. The increased illumination improved the worker's ability to see the work area and the work task, and was thought to positively impact the quality of safety. The balloon lights were easy to set up and again reduced the likelihood of glare to oncoming motorists. Therefore, researchers recommend the continued use of balloon lights to improve work area lighting and reduce glare. ODOT also successfully used a mobile barrier with many different types of operations. Researchers feel that the advantages outweigh the challenges, and thus we recommend the continued use of the mobile barrier to improve worker safety as well. With that, I will put up my contact information in case there's someone that has a question that they want to ask me offline after we're done, and I will open it up to questions.
All right, Melissa.
Yes, ma'am.
Okay, we have unmuted everybody. So if anybody online has any questions, please feel free to ask them. Does anybody in the audience here have any questions? Is that a no? Sean, I would like to take a minute just for you, because you were Franklin County. You used them. Number one, we did already switch to Class 3. Is that correct?
Correct.
Okay. And the halo lights, there's other districts that are using them as well. So the halo lights and the apparel have already been changed. How about the balloon lights?
Can they?
Okay,
Jill, we can't hear him.
okay. Come on up here, Sean.
I was saying that we do continually use the
I'm having you.
using the class 3 apparel with the lights during the
Okay. Could y'all hear that? And then the mobile
No,
barrier.
I couldn't hear it.
Okay. Say it again.
We are still currently using the balloon lightings on the equipment as it was described in the presentation, and also the class 3 apparel with halo lights are being used during the traffic control setups at night as well.
And what about the mobile barrier? Are we using that more? Are we becoming more efficient at that?
Definitely more efficient, using it on the same types of projects at night, and probably about the same frequency.
Okay. So would you say for assessment of how it's being used with the other equipment, the ability to have the electrical outlets out there, the lights that come down, you found that beneficial? And then I'm going to ask you, can other districts borrow that piece of equipment as well?
Yes, yes to all of that. And we've been contacted by several districts that are interested in using it. We have had one District 7 recently borrowed it for a display project with some interest of using it as well. I will add one additional thing about the Columbus MOT truck. Research is ongoing, experience is ongoing. We have recently fabricated our third MOT truck, and on that third MOT truck, we have added a fold-down additional platform so that when the barrel or the cone is lifted from the roadway, instead of being lifted onto that platform that's 12 inches off of the roadway, it'll be lifted 12 to 14 inches higher than that onto a fold-down platform, so the person that's in the bed of the vehicle does not have to reach over quite as far to retrieve that device.
Any questions?
There seems to be a question in the chat box that says Class 3 vest with sleeves required for dark conditions. Class 3 performance apparel is required. You can do that just with a vest with sleeves, but the Franklin County group opted to keep their Class 2 vests because they could wear those if they needed to be out during the day too, and add the Class E pants. Class E pants by themselves cannot be worn alone. But when they're put with a Class 2 vest, they become a Class 3 performance ensemble. So you can do it the way they did it and it still meets Class 3 requirements, or you could just switch completely to a Class 3 vest and not have the pants. But with that said, you can see from the data in the visual angle part that if you just added, you would get, the illuminance the silhouette luminance may be the same because the amount of area of your retroreflective material would be the same. It would just be in different locations. But your visual angle would not be as great if you don't add the pants, because what the pants give you is that extra length to see there's a leg down there and extends that visual angle so you can tell it's a body. If you just put that in the upper portion on the sleeves, you'll still just have all that in a smaller visual angle area. So personally, I still think that using the pants is a good option because it extends that visual angle. And Class 3 can be used during the day too. We were mainly looking at it for our the nighttime crew there in the Columbus area. But as I showed in one of our pictures, the more fluorescent material you put on yourself, you can also see your work crew better during the day. So the option of the pants or added sleeves during the day can help with that as well.
Excuse me, I have 2 questions. I'm with District 3. I'm the safety consultant. The first question I have, is this presentation going to be available online somewhere?
Yes, it'll be online on the research website.
Research website, okay. Okay, next question I have. The safety SOP presently says that Class 3 is only required by flaggers, for the flaggers at night. Is this something that how do we go about changing that safety SOP? Or is that something that you think we need to change? Because if they say only the flaggers have to have it, where the rubber meets the road out there on them work crews, those are the only ones a lot of times that wear them. If we had the SOP changed so they had to wear Class 3 at night, everybody in night operations, I think that would help significantly.
Right. So from my researcher standpoint and the findings of this research effort, I would recommend that Class 3 be required at night for all workers.
Okay, thank you.
Now,
I appreciate it.
How you accomplish that, whether it just be with a vest or whether it be with a vest and a pant, would be something y'all could discuss among yourself. But I would just at least require Class 3 at a minimum. Now, again, I am a promoter of using the pants because it extends the visual angle. But at a minimum, I would recommend that you change that SOP to require everyone at night to wear Class 3.
Okay, thank you. Great study. Thank you.
I have a question.
Go ahead.
Hello?
Go ahead.
The halo light. The halo light, is it just for to be seen, or will it put out enough light that you can kind of see what you're doing?
No, it really was primarily bought and applied to provide individual task lighting. So it puts out plenty of light for you to be able to see working around you. It gives you 360 degrees of that light so other people can see around you as well. It is not blinding. The way it's designed, it helps keep that light kind of on the pavement. So, if you use like a single headlamp or something, you look down, you can see, but you look up and somebody start talking to them, you can kind of blind them. You don't necessarily have that with the halo. So ODOT primarily purchased it, and we looked at it to provide individual task lighting to a worker, whether they were walking along putting out traffic control or whether they had to leave the more lit area to travel back to a truck, or say the gentleman was on the roller or something that was going in and out of the primary lit area. But it also, as we showed in the photometric evaluation, does help increase that visual angle. So it does add to, the ability of a person to hopefully help distinguish a motorist amongst all the temporary traffic control devices.
Okay, thank you very much. That's all I have.
Any more questions? You got something? Okay. Thank you for attending. This will be online. Sometime tomorrow, you should be able to access the research website and the study will be available. Thank you. Thank you, Melissa.
Thank you. Appreciate it.